Okay, let's talk about finding the smartest path. Not just any path, but the most efficient way to get from point A to point B. We're going to pull back the curtain on one of the coolest algorithms out there that does exactly that.
You've definitely seen this in action, right? I mean, how does your GPS just know the fastest way to get you out of a traffic jam? Or think about a video game. How does that enemy AI navigate a super complex map and come right for you? It feels like magic, but nope. It's just some really, really clever math.
Well, the secret sauce in all of those things, it's an algorithm called A-Star. It's the brains behind the operation for game AI, your car's navigation, even those robots you see zipping around in warehouses. It's everywhere.
So let's get into it. How does a computer actually solve this quest for a path? I mean, it can't just try every single possible route, right? That would take forever. It needs a way to be smart about it.
And that's exactly where A-Star comes in. It's what's called a best-first search algorithm, which is a fancy way of saying it doesn't just wander around hoping to stumble on the answer. No, A-Star is way smarter. It makes educated guesses. At every single step, it's thinking, what's my most promising move right now? Okay, so how does it make these educated guesses? What's the secret? Well, it all boils down to this one beautiful little formula. A formula that's all about balancing what's already happened with a smart guess about what's to come.
And here it is, the secret formula. F of n equals g of n plus h of n. It looks simple, and it kind of is. So f of n is the total score for a path. A-Star always wants the path with the lowest score. G of n is the easy part. That's the actual cost to get from the start to wherever we are right now. We know that for sure. And h of n, that's the magic. That's the heuristic, which is just a fancy word for our educated guess of how far it is from here to the finish line.
Let's use an analogy, because that makes everything easier. Think of G of n as the road you've already traveled. You've been on it, you know exactly how long it is. No guesswork there. Then you've got h of n. That's your guess. It's like looking at a map and saying, well, as the crow flies, it looks like it's about this far. It's that straight line, best-case scenario guess that guides the whole thing.
All right, that's enough theory. Let's actually watch this thing work. We're going to follow A-Star on a little journey and see how it thinks.
So here's the basic playbook for A-Star. It keeps two lists. Think of one as an open list. These are the places it could go next. And the other is a closed list, places it's already been, case closed. It starts with, well, the starting point on its open list. Then it just repeats a simple loop. Grab the spot from the open list that has the absolute lowest score. Check if it's the finish line. If it is, awesome, we're done. If not, it moves that spot to the closed list, looks at all its neighbors, calculates their scores, and throws them onto the open list. And it just keeps doing that over and over.
Okay, let's do a quick run through. Super simple goal. We need to get from node 0 over to node 4. Let's see how A-Star pulls it off.
All right, we're at the starting line, node 0. A-Star looks at its immediate neighbors. It sees two options. Going to node 1 costs 1 unit, and the guess to the end is 6. Total score, 7. The other option, node 2, costs 4 units to get to, but the guess to the end is only 2, so its total score is 6.
Now, here's the crucial part. Even though node 1 is cheaper to get to right now, A-Star doesn't care. It's looking at the total estimated cost. And a score of 6 is better than a score of 7. So it decides to explore the path through node 2 first. It's playing the long game. That's the smarter bet.
Okay, so now we're at node 2. And guess what? The process just repeats. It's the same dance all over again. A-Star looks at the neighbors of node 2, calculates their FN scores, and compares them to any other options it still has on its open list. It is always, always picking the path with the lowest total score to explore next.
And that's really the whole trick. It's this constant balancing act between the known cost, the road already traveled, and that smart guess about the road ahead. By doing that over and over, it just zeroes in on the best possible route. And there you have it, success. The best path from our start to our finish has a total cost of 9. And notice, it found this without having to explore every single dead end along the way. Super efficient.
So to really appreciate just how clever A-Star is, it helps to put it side by side with another famous pathfinding algorithm called Dijkstra's. Because the difference between them really comes down to one thing, that little guess, the h of n.
Okay, so here's the deal. Dijkstra's is like super thorough. It only cares about the actual costs so far, the g of n. So it just expands outwards from the start in every single direction, kind of like ripples in a pond. It's guaranteed to find the shortest path, But man, it can be slow because it explores so much unnecessary space. A*, with its g of n plus h of n, is way more focused. That h of n guess acts like a compass, always pointing it toward the goal. It doesn't waste time exploring in the wrong direction.
And this is the part that blows my mind. If you take A*'s formula and you set that guess, the h of n, to 0, you've just created Dijkstra's algorithm. That's it. That's the only difference. That one little forward-thinking guess is what separates being thorough from being smart.
And you can see the difference plain as day right here. When you look at how many different spots, or nodes, each algorithm has to check, Dijkstra's is working way harder. A*'s focused approach means it gets to the answer by exploring way fewer options. That's a huge deal for performance.
So what's the big idea here? What are we really talking about? It's about the incredible power of making a good guess. And that idea goes way beyond just maps and video games.
So let's wrap our heads around the genius of A*. First, it perfectly balances facts, what it already knows, with a smart guess about the future. Second, because of that guess, it directs its search toward a goal instead of just wandering around. Its speed and efficiency, that comes down almost entirely to how good that guess is. And what this all does is transform a problem that could be impossibly huge into something a computer can actually solve, and solve fast.
And that really brings us to the big question, doesn't it? This whole idea of combining what you know for sure with a smart, educated guess about where you're headed, that's not just a programming trick. It's a fundamental strategy for solving tough problems. So think about it. Where else could a little bit of A* thinking help find a smarter path through a problem that seems impossible?